Welcome to this video on using local storage with Flutter. After watching this video, you'll be able to analyze the importance of local storage and use it to your advantage. You will also recognize the relevance of integrating local storage into your applications, analyze how you can integrate different local storage methods effectively, and apply best practices for local storage to ensure optimal app performance. Imagine a team of Flutter developers working on a productivity app that tracks daily tasks and progress. They quickly realized that users would lose all their saved tasks and preferences without data persistence whenever they close the app. They integrate local storage to prevent this, ensuring users can access their task lists and progress offline. Local storage has helped the app become reliable and functional, regardless of network availability, and keeps users engaged. Local storage equips your app with the ability to save data directly on a device. This feature is essential for mobile apps that need to retain user settings, state, or cache data, allowing them to function offline and improve performance by reducing load times. The integration of local storage requires a deep understanding of how data flows and persists within your app throughout its lifecycle. This involves knowing when and where to store data and how to retrieve and manage it as the app operates, closes, or restarts. Next, let's examine how to deploy data persistence using options such as shared preferences, SQLite, Hive, files, and local storage. Before diving into code, it's important to set up your chosen storage method at the launch of your app. This ensures that your app is ready to store and retrieve data throughout its lifecycle. Whether you're using shared preferences or Hive, initializing the storage early in the app's lifecycle provides immediate access to stored information. For example, here we initialize an instance of shared preferences. To effectively manage data within your application, you should implement CRUD operations, a set of functions dedicated to creating, reading, updating, and deleting data. You should ensure these functions are easily accessible in your app. This line demonstrates the creation operation by saving a new integer value of 10. This line illustrates the read operation by retrieving the integer value. And finally, this line shows the delete operation by removing the stored value. Proper data storage and retrieval are essential when working with complex data structures. One effective approach is to encode and decode data in JSON format. This process is particularly useful when utilizing methods like local storage or when dealing with files, as it allows for seamless serialization and deserialization of your data. This line imports the Dart convert library, which provides functions for encoding and decoding data in various formats, including JSON. This function takes a JSON string and converts it into a Dart object. The result of this function is assigned to user map. This line has the from_JSON method taking user map and creating an instance of the user class. Incorporating Flutter's state management solutions such as Provider, Block, or Riverpod enhances your application's interaction with local storage. These solutions help create a reactive architecture, ensuring that changes of the data stored locally are immediately reflected in the user interface. This code snippet demonstrates how to use the Provider package to manage user data stored in local storage. The class userProvider is defined to manage user-related data. Change Notifier enables the class to notify widgets when there are changes. This variable holds the user information loaded from local storage. This method is responsible for loading user data from local storage. Here, a JSON string is retrieved and then decoded. This method is called with the decoded data to create a user object. After loading user data in this variable, notify listeners is called. This method informs all widgets that user data has changed. Always encrypt sensitive data to ensure that data remains protected even if unauthorized access occurs. Only store necessary data to minimize read-write cycles and storage usage. This optimizes data storage, enhancing app performance, and improving overall user experience. This is particularly useful on devices with limited storage capacity. Maintain a consistent schema for stored data and handle migrations properly when the schema changes. This approach allows for smooth updates and ensures that all parts of your app can accurately interpret and work with the stored data. In this video, you learned to assess the importance of local storage and its significance for retaining user settings, state, or cache data. Use initialization code to initialize storage early in your app's lifecycle. Implement CRUD operations such as creating, reading, updating, and deleting data. Perform serialization and deserialization by encoding and decoding data in JSON format. Integrate state management solutions to ensure that changes are immediately reflected in the user interface. Apply best practices for local storage to ensure optimal app performance.